Okay, now what screen you are seeing?
Polarization, sir.
Very good, that's fine, then it is okay. Okay, so as I said, in ferroelectric materials, this polarization is very important. Okay, so by definition, polarization is the charge into the distance. Okay, so the charge, two charges separated by a distance d. So by definition, the polarization is defined as charge times the distance. Okay, so this is very important for the whole unit. Okay, so now the mu, which is called as induced dipole moment. Okay, so mu is the induced dipole moment. It depends on, it is directly proportional to the applied electric field E. Okay, so can you see the mouse which I am moving?
Yes, sir.
Okay.
Yes, sir.
So the dipole moment is directly proportional to applied electric field. So when you increase the electric field, what will happen? Your polarization will increase.
Dipole moment
Yeah,
increases.
the dipole moment will increase. Okay, so if I put a constant, that is called as polarizability. So this polarizability is a material property. This is a constant for all the materials. Okay, so this is what we are going to study, the polarizability. Okay, so dipole moment is polarizability times the applied electric field.
Applied electric field.
Okay, okay, fine then. Okay, so there are 4 types of polarization. The first one is called as electronic polarization. So can you see that screen now?
Yes, sir.
Yes, sir.
Okay, so electronic polarization, ionic polarization, orientation polarization, and the space charge polarization.
Space charge polarization.
So all the materials will have this common electronic polarization, because this electronic polarization arises from the atom. Okay, so this is one of the most important polarization, which is we are going to study now. Okay. So this question, types of polarization, is one of the important part B questions for your university exam. Okay, so they will ask the derivation. So electronic polarization and ionic polarization derivation is important for your university examination. Okay, so the electronic polarization arises from the atoms. Okay, so we will see that definition in the next slides. Okay, so the ionic polarization, you know, ionic materials, for example, sodium chloride, in which sodium is a positively charged ion and chlorine is a negatively charged ion. When you apply when you apply electric field, the ions will move. Apart from the atoms, the ions itself will move. So that is called as ionic polarization. Okay, in the orientation polarization, the whole molecule will orient. We have studied organic molecules. The whole molecules will orient. Okay, in orientation polarization, you will be having both electronic polarization and ionic polarization. Both electronic polarization, but and ionic polarization if it is a ionic molecule. But the contribution from these two will be less when you compare with this whole orientation polarization. Okay, so the electronic polarization is a base to all these polarizations. Okay, space charge polarization is not the material property, that is a device property that comes because of the effects. Okay, so that I will show you in the next slide. Okay, so again, now what you are saying?
Polarization.
Polarization. There are 4 parts, right?
4 polarization. Yes,
Okay,
sir.
fine. Okay. So in electronic polarization, before applying the electric field, for simplicity, let us suppose that, as imagine, as usual, like your atom is a spherical atom. Okay, your atom is a spherical atom. But after applying electric field, what will happen? The electrons will assemble on one side. It will orient towards the applied electric field. So your atom will no more a spherical atom. Now it will become elongated. When you apply electric field,
Ellipsoid. Yes,
yeah,
sir.
it will become like a ellipsoid. So this is the difference between the distance. Okay, so your dipole is created because of this charge difference. Previously, there was no charge difference. Okay, so it was uh, it was like the polarization is zero. There is no dipole. When you apply electric field, you are creating a dipole. Okay, so similarly in ionic polarization, before applying electric field, the sodium chloride ions will place at a even distance. So the polarization will be zero. When you apply electric field, the ions will move towards the applied electric field. So you are creating a polarization. Polarization is not equal to zero. Similarly,
Yes,
in
sir.
orientation polarization, as I said before, these are all molecules, your organic molecules, each one of it. When you apply electric field, your your molecules, the whole molecules will orient. Okay, now you are creating polarization. In the case of space charge polarization, okay, so these are the charges created on the grain boundaries. So in the last semester, in the 5th unit, we have studied about the single crystal and the polycrystalline material. Okay, in
Yes, sir.
polycrystalline material, you will have many minute crystallites. Okay, called as grains. Okay, on the grain boundaries, you will create some charges, and also in your parallel plate capacitor, on your parallel plate capacitor, you will be having two electrodes. We will be having two electrodes, right?
Yes,
And
sir.
in between the electrode and your dielectric material, there will be some space. Okay, some charges will
Yes,
get
sir.
stored on that space. That is called as space charge polarization. Okay, so this is a defect based polarization. So we are not going to concentrate on space charge polarization. We are going to concentrate only on electronic polarization and ionic polarization. Okay, so the derivation on electronic polarization and ionic polarization. Okay, so now I have copied these things from the materials which I have sent. Okay, so how how uh, the electronic polarization, the polarizability alpha, which is called as for electronic polarization alpha E, how it can be calculated. Okay, so without electric field, that is before applying electric field, as I said, we are considering a spherical molecule. Okay, the spherical molecule. So the charge density rho, the charge density rho is given by charge of the electron by the volume of the
Volume
atom.
of atom.
Okay, as we are considering spherical atom, the volume of the atom is going to be 4 by 3 pi r cube,
Cube.
where r is the radius of the atom. Okay,
That.
and E is the charge of the electron, and Z is the what usually
Atomic
Z
number.
we will call that as atomic number. So if you
Atomic
call the
number.
atomic number,
Atomic number.
the atomic number will give the number of electrons. So this will give Z will give the number of electrons. Can you hear me now?
Yes,
Yes,
sir.
sir.
Okay. So there is a net problem. Okay. So Z gives the number of electrons and E is the charge of the electron. So when you take one atom, so Z gives the number of electrons. So the total charge will give Ze is the total charge divided by the volume of the electron, which is 4 by 3 pi r cube. Okay. So when I simplify this, this will give indicates minus indicates
Charge of the
charge
electron.
of the electron, which is negative. Okay, so the charge
Negative.
density is minus 3 by
3
by
4 pi
4 pi cube.
r cube.
Pi r cube.
So this is the charge density of the electron atom, charge density of the atom before applying electric field. So we are going to see what will happen if I apply electric field. So with electric field, there are two forces acting. Okay, one is called as Lorentz force. You apply electric field, the Lorentz force will act and try to separate, okay, your positive ion and negative ion. That's why you are creating the polarization. Okay, so your electrons will orient on one direction. Okay, so that is the uh, Lorentz force. Okay, so again, there is a Coulomb force. There will always be attractive force between your nucleus and the electron. That's the Coulomb force. Okay, that will always have. Okay, so at equilibrium condition, these two forces are
Both
equal.
should
The
be
Lorentz
equal.
force will be equal to the Coulomb force.
The
We are
Coulomb
going
force.
to equate that. That's what we are going to do now. Okay. So the Lorentz force is given by the charge of the electron by the applied electric
And the
field.
electric.
So the electric field, we know how much field we are applying, which we consider as E. Okay, so that is E. The charge, the total charge of the electron, which is ZE. Okay.
ZT.
So the Lorentz force is given by ZE, which is the charge of
ZEE.
total charge of the electron multiplied by the applied electric field. Okay. In Coulomb force is given by product of the charges. Coulomb force is directly proportional to the product of the charges,
Product of the
inversely
charges
proportional to
inversely
the square of the
proportional to square of distance between them.
Okay, so the distance R is the distance of separation between your nucleus and the electron cloud. So that you should remember here. Okay, so that is the difference, and 4 pi epsilon naught is a constant. So the Coulomb force is given by Q1 Q2 divided by
Q2
4
by
pi epsilon naught R square, where Q1 is the positive charge, okay, nucleus. We are taking that as a point charge. Nucleus we are considering as a point charge. Okay, so Q2 is the charge due to the electron cloud, and R is the distance of separation.
distance between them.
Distance of separation, your nucleus and the electron cloud. Okay, so that is fine. Okay, so the radius R here we are considering as X, the distance which is moved. Okay, so the electron cloud, the nucleus and the electron cloud. So the Coulomb force therefore is given by the total positive charge. What is total positive charge? It is ZE. Okay, so because the number of electrons and number of protons in an atom is going to be equal, so the total positive charge is going to be ZE, and then total negative charge enclosed in the sphere of radius X, which we are going to calculate. Okay, by 4 pi epsilon naught, which is a constant. Epsilon naught is the permittivity of vacuum, which is a constant, and X is the distance. Okay, so the total negative charge is the total negative charge we are going to calculate, which is given by charge
Density into
volume of the sphere. Okay, now the thing you should remember, volume of the sphere is not 4 by 3 pi r cube, where r is the radius of the atom. This is 4 by 3 pi x cube, because now x is the radius of your sphere, this deformed sphere. Okay, so that you should remember. Okay, so the total negative charge ZE, okay, this is 4 by 3 pi x cube, volume of the this distorted sphere. Okay, so this is the charge density. This is the charge density which we have calculated before applying electric field. This is minus 3 ZE by 4 pi r cube. This is the charge density which we calculated before applying electric field. This is the volume 4 by 3 pi x cube. So this you should remember. X is the distance of separation between your positive charge and the electron cloud. Okay, so the total negative charge, if I simplify this 4 pi and 4 pi will get cancelled, 3 and 3 will get cancelled. So I will be having minus ZE x cube divided by r cube. Okay, so as I said before, the total positive charge is Z into E, because the number of electrons and number of proton is going to be the same. Okay. So the Coulomb force we can calculate now as ZE into minus ZE into x cube by r cube, which we have calculated here. Total negative charge divided by 4 pi epsilon naught into x square, which is the radius square, which is there in the formula.